In the days of old, when the gods walked among men, fire fell from the heavens and the earth trembled. The great waters rose and consumed the cities of the ancients. Only those who had been warned survived to tell the tale. And the gods said, "We shall begin again." From the Sumerian flood tablets circa 2100 BCE, what if 12,900 years ago, an event occurred so catastrophic that it erased an entire advanced civilization from history? What if the myths of a global flood, of fire raining from the sky, of the earth opening and swallowing cities, were not mythology, but memory? Could the sudden climate catastrophe known as the Younger Dryas represent not a random geological event, but a cosmic reset button that ended the first chapter of human civilization? In geological records preserved in ice cores from Greenland, in sediment layers from hundreds of sites across North America and Europe, in the oral traditions of indigenous peoples on every inhabited continent, and in the ruins of megalithic structures that predate known civilization, we find evidence of an event so profound, it divided human history into before and after. The Younger Dryas, named after a flower called Dryas octopetala that proliferated during the cold period, marks an abrupt return to Ice Age conditions lasting approximately 1,300 years, from 12,900 to 11,600 years ago. This happened at the end of the last glacial period, when temperatures had been warming for several thousand years. Glaciers were retreating, sea levels were rising, and the planet was transitioning toward the relatively stable Holocene climate we have enjoyed for the past 11,600 years. Then suddenly, within perhaps a single decade or even less, temperatures in the northern hemisphere plummeted back to full glacial conditions. Ice sheets that had been melting began advancing again. Ocean circulation patterns that distribute heat around the planet disrupted catastrophically. Ecosystems that had adapted to warming climate were devastated. And according to controversial but increasingly supported theories, the trigger was not gradual climate processes, but a cosmic impact event. Multiple airbursts and impacts from fragments of a disintegrating comet that struck the Earth with force sufficient to fundamentally alter the planet's climate and destroy whatever advanced human societies existed at that time. Conventional archaeology maintains that 12,900 years ago, humans were Paleolithic hunter-gatherers, living in small mobile bands, possessing stone tools, practicing seasonal migration following animal herds and plant resources, and lacking any form of complex social organization, monumental architecture, agriculture, writing, or civilization as we define it. The conventional timeline places the emergence of civilization at approximately 6,000 years ago in Mesopotamia, with the Sumerians, or at most extending back to 9,600 BCE with sites like Göbekli Tepe in Turkey. Before that, nothing but primitive nomadic existence. But what if this timeline is wrong? What if complex civilization existed before the Younger Dryas cataclysm, thrived during the relatively warm and stable climate of the late Pleistocene, and was systematically destroyed by the cosmic disaster that initiated the Younger Dryas, leaving only fragments of its existence in megalithic ruins, flood myths, and encoded astronomical knowledge preserved by survivor populations who rebuilt civilization over subsequent millennia? What we're about to explore are propositions highly controversial within mainstream archaeology, geology, and climatology. These interpretations challenge established academic consensus about when civilization began, what caused the Younger Dryas climate event, and whether advanced human societies existed before the accepted historical timeline. As Aristotle once wrote, it is the mark of an educated mind to entertain a thought without accepting it. What follows requires an open mind willing to examine evidence that contradicts conventional narratives, while maintaining intellectual rigor and healthy skepticism. We will present both the mainstream scientific understanding of the Younger Dryas and the alternative hypothesis that it represents a cosmic impact that destroyed a pre-existing advanced civilization, allowing you to examine the evidence and draw your own conclusions about one of the most pivotal yet least understood events in human prehistory. The Younger Dryas takes its name from the Arctic alpine flower Dryas octopetala, an indicator species that thrives in cold tundra conditions. When palynologists, scientists who study ancient pollen preserved in sediment layers, examined cores from bogs and lakes across northern Europe, they discovered a distinctive pattern in the vegetation record. As the last ice age ended and temperatures warmed from approximately 14,700 years ago, tree species including birch and pine expanded northward, replacing the tundra vegetation that had dominated during glacial maximum. This transition is called the Böhling-Allerud interstadial, a period of relatively warm conditions when temperatures approached or even exceeded modern levels in some regions. The climate was improving, glaciers were melting rapidly, and the planet seemed headed toward the warm interglacial conditions that would eventually stabilize in the Holocene. But then, abruptly visible in the pollen record as a sharp boundary, the trees disappeared and tundra vegetation, including Dryas octopetala, returned, indicating a sudden shift back to cold conditions. This cold reversal lasted approximately 1,300 years before temperatures rose again even more abruptly, transitioning into the Holocene warm period that continues today. The younger Dryas was first identified in Scandinavian pollen records in the early 20th century, but subsequent research revealed it was not a local phenomenon, but a global or at least hemispheric event with profound impacts on climate, ecosystems, and potentially human populations. High-score data from Greenland provides the most detailed climate record of the younger Dryas transition. The Greenland ice sheet cores, including GESP2 and GRIP, contain annual layers of ice that can be counted like tree rings, providing a year-by-year record of temperature and atmospheric composition extending back over 100,000 years. Analysis of oxygen isotope ratios in the ice, which serve as a temperature proxy, reveals the extraordinary abruptness of the younger Dryas boundaries. The onset at approximately 12,900 years ago saw temperatures drop by an estimated 15 degrees Celsius in Greenland, within a span of perhaps 10 years or less based on the ice core resolution. That is not a gradual climate shift, but a catastrophic climate collapse occurring within a single human lifetime, possibly within a single decade. The termination of the younger Dryas at approximately 11,600 years ago was even more abrupt, with temperatures rising by perhaps 10 degrees Celsius in as little as 3 years, according to some ice core interpretations. These are not the gradual climate transitions that characterize natural orbital forcing or slow feedback mechanisms, but rapid state changes suggesting a system pushed past a tipping point by external forcing. The conventional explanation for the younger Dryas, widely accepted in geology and paleoclimatology textbooks until recently, invokes disruption of ocean circulation patterns, specifically the Atlantic Meridional Overturning Circulation, or AMOC, the system of currents that includes the Gulf Stream and distributes heat from tropical regions toward the North Atlantic and Western Europe. The hypothesis, developed primarily by Wallace Brooker and colleagues in the 1980s and 1990s, proposes that as the Laurentide ice sheet covering much of North America melted during the Böhling-Allerud warming period, enormous volumes of fresh water accumulated in proglacial lakes dammed behind ice barriers. Eventually, these ice dams failed catastrophically, releasing massive floods of fresh water into the North Atlantic. Because fresh water is less dense than salt water, this sudden influx would have formed a low-density surface layer that disrupted the normal sinking of cold, dense, salty water in the North Atlantic that drives the AMOC circulation. With the circulation weakened or shut down, heat transport from the tropics to the North Atlantic ceased, causing temperatures in that region and across the Northern Hemisphere to plummet back to glacial conditions. This explanation has the advantage of invoking only known natural processes. Catastrophic outburst floods are well-documented geological phenomena, and ocean circulation changes are understood mechanisms for rapid climate change. For decades, this meltwater pulse hypothesis was considered the settled science explaining the younger Dryas. However, significant problems with this explanation have emerged. First, the geographic routing of the meltwater remains contentious. Early versions of the hypothesis proposed that water drained eastward through the Great Lakes and St. Lawrence River into the North Atlantic. Later research suggested it might have drained northward through the Mackenzie River into the Arctic Ocean. But finding definitive geological evidence for the timing and magnitude of these flood events that matches the younger Dryas onset has proven elusive. Second, The meltwater hypothesis struggles to explain evidence of younger Dryas climate impacts in the southern hemisphere and tropics. If the trigger was disruption of North Atlantic circulation, why do we see synchronous climate changes in South America, New Zealand and tropical regions that should not be directly affected by AMOC shutdown? Some researchers argue for global climate teleconnections, but the mechanisms remain unclear. Third, and most problematically, detailed ice core analysis reveals that the onset of the younger Dryas coincides with significant changes in atmospheric composition and depositional patterns that are not easily explained by ocean circulation changes alone. There are peaks in certain chemical markers, changes in dust deposition, and most intriguingly, the presence of materials that suggest extraterrestrial input. This brings us to the alternative hypothesis that has gained increasing scientific support, despite intense resistance from parts of the academic establishment. The younger Dryas impact hypothesis, initially proposed by Richard Firestone, Alan West, Simon Warwick Smith, and colleagues in 2007, suggests that the abrupt onset of the younger Dryas resulted from a cosmic impact event, specifically multiple airbursts and possible ground impacts from fragments of a large comet that disintegrated as it entered Earth's atmosphere over North America and possibly other regions approximately 12,900 years ago. The evidence for this hypothesis comes from a distinctive layer found at hundreds of sites across North America, Europe, and increasingly at sites in other continents, dated precisely to the younger Dryas boundary at 12,900 years ago. This layer, called the Younger Dryas Boundary Layer or YDB, contains a suite of materials and markers that proponents argue can only be explained by cosmic impact. These include nanodiamonds, microscopic diamonds that form under the extreme temperatures and pressures of impact events, found in concentrations far higher than background levels. Magnetic microspherules, tiny spheres of melted and resolidified magnetic minerals that form when impact energy melts soil and rock, which then rapidly cools into spherical droplets. High-temperature iron-rich microspherules containing iridium and other platinum group elements in ratios suggesting extraterrestrial origin. Carbon spherules consistent with biomass burning at temperatures exceeding what normal wildfires can achieve. Melt glass, silica-rich glass formed by melting of sand and rock at temperatures above 2,200 degrees Celsius. And perhaps most compellingly, nanodiamonds in two distinct forms: cubic diamonds and the much rarer hexagonal diamonds called Lonsdaleite, which on Earth are found almost exclusively in impact structures and have been experimentally shown to require the shock pressures of hypervelocity impact to form. But there is something even more disturbing in the evidence that we will return to later, a detail that connects the younger Dryas not just to climate catastrophe and potential civilizational collapse, but to a recurring cosmic threat that may still endanger Earth today. That detail involves the orbital dynamics of the proposed comet and what it implies about the ongoing risk of similar impacts in our current era. Before we explore that connection, we need to understand the full scope of what the younger Dryas impact hypothesis claims happened 12,900 years ago and why it matters for understanding lost civilizations. According to the impact hypothesis, a large comet, possibly 100 kilometers or more in diameter, entered the inner solar system on an Earth-crossing orbit and began fragmenting, perhaps due to tidal forces as it passed close to the Sun or through previous fragmentation events. By the time the debris stream encountered Earth approximately 12,900 years ago, it consisted of multiple large fragments, ranging from kilometers to tens of kilometers in diameter, along with vast amounts of smaller debris. As these fragments entered Earth's atmosphere at cosmic velocity, likely 20 to 50 kilometers per second, they created massive airbursts, similar to but far larger than the Tunguska event of 1908, where a relatively small asteroid or comet fragment, estimated at 50 to 100 meters across, exploded in the atmosphere over Siberia with energy equivalent to 10 to 15 megatons of TNT, flattening 2,000 square kilometers of forest. But the younger Dryas impactors would have been orders of magnitude larger, creating airbursts with energies measured in hundreds or thousands of megatons, perhaps even gigatons, equivalent to the largest thermonuclear weapons ever tested, but concentrated in specific impact zones. These airbursts would have generated thermal radiation intense enough to ignite biomass across entire continents, creating firestorms that consumed forests, grasslands, and potentially human settlements. The shockwaves would have created winds exceeding hurricane force, flattening structures and vegetation across thousands of square kilometers around each impact site. The impacts or airbursts over ice sheets would have melted enormous volumes of ice, contributing to rapid sea level rise and potentially injecting vast amounts of water vapor into the atmosphere. Debris ejected into the upper atmosphere would have spread globally, creating a dust veil that reduced solar radiation reaching the surface, triggering rapid cooling. Soot from continental-scale wildfires would have further blocked sunlight, creating impact winter conditions similar to the nuclear winter scenario that scientists fear would follow a major nuclear exchange. The combination of thermal pulse, blast effects, fires, ice melting, dust injection, and subsequent cooling would have created a perfect storm of catastrophe sufficient to destroy ecosystems, extinguish megafauna species, and devastate any human civilizations unfortunate enough to exist in the impact zones or dependent on the affected ecosystems. The conventional scientific response to the Younger Dryas impact hypothesis has been mixed, ranging from interested engagement to outright hostility. In the years following its initial proposal in 2007, numerous papers were published challenging various aspects of the evidence, questioning whether the materials found in the YDB layer truly indicated impact, proposing alternative explanations for each marker, and arguing that the hypothesis was not supported by sufficient evidence. Critics pointed out that nanodiamonds can form through processes other than impact, that magnetic spherules can result from cosmic dust influx that occurs continuously rather than from a discrete impact event, that carbon spherules and melt glass might result from intense wildfires rather than cosmic impact, and that the distribution of supposed impact markers was inconsistent with a coherent impact event. Some critics suggested that proponents were seeing patterns in noisy data, that confirmation bias was leading them to interpret ambiguous evidence as supporting their preferred hypothesis. The debate became contentious, with accusations on both sides of insufficient rigor, selective presentation of data, and unwillingness to consider alternative interpretations. However, in recent years, the evidentiary basis for the impact hypothesis has strengthened considerably. Independent research teams have confirmed the presence of YDB markers at numerous additional sites across multiple continents, expanding the geographic footprint of the layer and demonstrating that it represents a globally significant event rather than localized phenomena misinterpreted as global. In 2018, a major study published in the Journal of Geology confirmed the presence of platinum anomaly at the Younger Dryas boundary, elevated platinum concentrations in a thin layer dated to exactly 12,900 years ago at 11 sites across the Northern Hemisphere, including locations in North America, Europe, and the Middle East. Platinum is rare in Earth's crust, but relatively common in asteroids and comets, making a sharp platinum spike strong evidence for extraterrestrial input at that specific time. Perhaps most significantly, in 2020, research published in Scientific Reports identified shocked quartz at a Younger Dryas boundary site in New Jersey. Shocked quartz is quartz crystal that has undergone deformation under extreme pressure, creating distinctive parallel fracture patterns called planar deformation features, or PDFs. On Earth, shocked quartz is found almost exclusively at confirmed impact craters and nuclear test sites, as it requires shock pressures exceeding 10 gigapascals that occur during hypervelocity impacts. The presence of shocked quartz at a YDB site provides compelling evidence that at least some YDB sites experience direct impact effects, not merely airburst phenomena. The correlation between the Younger Dryas onset and the extinction of North American megafauna provides additional context for understanding the scale of disruption. At the end of the Pleistocene, North America was home to a spectacular array of large mammals, including mammoths, mastodons, giant ground sloths, saber-toothed cats, dire wolves, American lions, short-faced bears, camels, horses, giant beavers, and numerous other species. These animals had survived previous glacial-interglacial cycles spanning hundreds of thousands of years, demonstrating their ability to adapt to climate change. Yet, between approximately 13,000 and 11,000 years ago, with the extinctions concentrated around the Younger Dryas boundary, at 12,900 years ago, 35 genera of North American megafauna went extinct, representing approximately 72% of large mammal diversity on the continent. This is not gradual extinction over millennia, but catastrophic die-off concentrated in a brief period. South America experienced similarly devastating megafaunal extinctions, losing 52 of 59 genera. Eurasia lost about 36% of its megafauna. Australia had already lost most of its megafauna somewhat earlier, between 50,000 and 40,000 years ago, but that extinction event may represent a separate, earlier impact or climate catastrophe rather than being part of the Younger Dryas event. The conventional explanation for these extinctions focuses on two possible causes: climate change associated with the end of the Ice Age and human overkill. The hypothesis that human hunters expanding into the Americas around 13,000 years ago hunted the megafauna to extinction. Both factors likely played roles, but neither explanation is entirely satisfactory. The climate change explanation struggles to account for why these animals, which had survived numerous previous climate shifts, suddenly went extinct during this particular transition. The overkill hypothesis requires believing that small populations of human hunters, armed with stone-tipped spears, could systematically hunt to extinction dozens of species, including animals like mammoths, that were formidable, dangerous, and not easily killed, accomplishing this extinction across two continents in perhaps a few centuries, leaving relatively little archaeological evidence of intensive hunting for many of the extinct species. The impact hypothesis offers a more parsimonious explanation. The megafauna were not gradually hunted to extinction over centuries or slowly driven extinct by climate change over millennia, but were catastrophically killed by the direct and indirect effects of cosmic impacts, firestorms that consumed their habitat, destruction of food resources, toxic atmospheric conditions following the impacts, and rapid climate deterioration that eliminated the ecosystems they depended on. The fact that extinction severity correlates with proximity to probable impact zones, with North America experiencing the most severe extinctions and regions farther from the impact zones experiencing less severe losses, supports this interpretation. Now, while conventional archaeology and anthropology maintain that human societies 12,900 years ago were small, mobile, technologically simple hunter-gatherer bands that would leave little archaeological trace and posed no risk of being completely erased by even a major catastrophe, alternative researchers propose a radically different picture. They argue that the warm period preceding the Younger Dryas, particularly between 15,000 and 13,000 years ago, provided optimal conditions for the development of advanced human societies with sophisticated architecture, agriculture, or at least intensive resource management, long-distance trade networks, astronomical knowledge, and possibly even written or symbolic recording systems. The evidence for this proposition comes from multiple lines of inquiry, including megalithic structures that conventional chronology cannot adequately explain, encoded astronomical knowledge in myths and monuments that suggests advanced observational capabilities, and the sudden appearance of complex civilizations in the early Holocene, apparently already possessing sophisticated knowledge rather than inventing it gradually. Consider Göbekli Tepe in southeastern Turkey, first excavated in 1995 and dating to approximately 9,600 to 8,200 BCE, making it 11,600 to 10,200 years old, constructed immediately after or during the final centuries of the Younger Dryas. This site contains massive T-shaped limestone pillars weighing up to 20 tons, arranged in circular enclosures, carved with elaborate reliefs of animals including lions, foxes, bulls, vultures, snakes, scorpions, and more. The sophistication of the architecture and artwork is extraordinary, yet this was supposedly built by hunter-gatherers who had not yet developed agriculture, pottery, or permanent settlements. Klaus Schmidt, the archaeologist who excavated Göbekli Tepe until his death in 2014, argued that the site's construction required organizational capabilities and labor mobilization, suggesting a complex society. and he famously stated that in this case, the temple came before the village, meaning that religious or ceremonial motivations drove the development of social complexity rather than agriculture enabling it as conventional models propose. But there is an alternative interpretation that Schmidt did not fully explore, but that alternative researchers find compelling. What if Göbekli Tepe was not built by primitive hunter-gatherers inventing monumental architecture for the first time, but rather represents a reconstruction effort by survivors of the Younger Dryas catastrophe, people who retained knowledge and technical skills from a more advanced pre-impact civilization, but lacked the resources and population to rebuild at the same scale? The enclosures at Göbekli Tepe were deliberately buried around 8,200 BCE, carefully backfilled with debris to preserve them, for reasons that remain mysterious. Standard interpretation suggests the site was ritually closed, or that changing religious beliefs led to its abandonment and burial. Alternative interpretation proposes that the builders, knowing they were living in the aftermath of a cosmic catastrophe and possibly fearing future impacts, created time capsules encoding astronomical knowledge and warnings for future generations, then buried them to ensure preservation through whatever future catastrophes might occur. The astronomical interpretation of Göbekli Tepe's pillars, developed most comprehensively by Martin Sweatman and Dimitrios Tsikritsis in their 2017 paper published in Mediterranean Archaeology and Archaeometry, proposes that the animal carvings on Pillar 43, the so-called vulture stone, represent constellations and that the overall scene depicts the sky at the time of the Younger Dryas impact event approximately 10,150 BCE based on precession calculations. Specifically, they identified the vulture as representing the constellation Sagittarius, the scorpion as Scorpius, and other animals as corresponding to constellations visible along the ecliptic, the apparent path of the sun through the sky. A headless human figure on the pillar is interpreted as representing the catastrophic impact, with the overall composition serving as a memorial and warning about cosmic catastrophe. Above the animal frieze is a circle containing a dot, which Sweatman interprets as representing the sun, with the entire panel encoding the date and celestial configuration at the time of the impact event. Conventional archaeologists have generally rejected this interpretation, arguing that we cannot assume prehistoric peoples conceptualized constellations the same way we do, that attributing specific astronomical knowledge to builders 11,600 years ago is anachronistic, and that the carving likely has religious or mythological significance that we cannot decipher rather than representing astronomical observation. However, Sweatman's analysis demonstrates statistically significant correlations between the animal positions and constellation positions at the proposed date, correlations that would be unlikely to occur by chance. Moreover, other pillars at Göbekli Tepe contain what appear to be astronomical symbols, including depictions of the sun, moon, and possibly planets or stars, suggesting the builders had sophisticated celestial knowledge. If the astronomical interpretation is correct, it has profound implications because it means that people immediately after the Younger Dryas possessed not just the technical skills to quarry, transport, and carve 20-ton stones, but also the astronomical knowledge to track precession, the slow wobble of Earth's axis that causes the positions of stars to shift gradually over thousands of years, completing a full cycle approximately every 26,000 years. Understanding precession requires systematic observations spanning many generations, recorded and transmitted across centuries or millennia. Hunter-gatherers, supposedly just emerging from Ice Age conditions, struggling to survive in a devastated post-catastrophe environment, should not possess such advanced astronomical knowledge unless they inherited it from an earlier civilization that had the stability, resources, and motivation to conduct systematic celestial observations over extended periods. This is why Göbekli Tepe is so significant to the lost civilization hypothesis. It appears to represent not the beginning of complex society emerging from primitivity, but rather the remnant of collapsed complex society, attempting to preserve crucial knowledge in durable stone monuments that might survive future catastrophes. Similar astronomical encoding appears at other megalithic sites, suggesting a global pattern of knowledge preservation by survivor populations. The Great Sphinx at Giza in Egypt has been the subject of intense chronological debate for decades because while Egyptology conventionally dates it to the reign of Pharaoh Khafra, around 2500 BCE, geological evidence suggests it may be far older. Robert Schoch, a geologist from Boston University, examined the erosion patterns on the Sphinx enclosure walls in the early 1990s and concluded that the erosion was caused primarily by rainfall rather than wind and sand. Since Egypt has been arid for thousands of years, this rainfall erosion suggests the Sphinx predates the desiccation of the Sahara, potentially dating to 7000 to 5000 BCE or even earlier, when the region received sufficient rainfall to produce such erosion patterns. If the Sphinx is indeed older than the Old Kingdom, it could represent pre-dynastic Egyptian civilization or potentially a pre-Younger Dryas civilization, with later Egyptians renovating and incorporating it into their own structures. The Sphinx faces directly east toward the sunrise at the equinoxes. Computer simulations of the sky as it appeared thousands of years ago using precession calculations reveal that around 10,500 BCE, at dawn on the spring equinox, the Sphinx would have faced its own constellation, Leo the Lion, rising on the eastern horizon. This astronomical correlation has led alternative researchers, including Graham Hancock and Robert Bauval, to propose that the Sphinx was constructed approximately 12,500 years ago to mark the precessional age of Leo, with its leonine form representing the constellation that rose in the east at that time. Conventional Egyptologists reject this dating, noting that there is no archaeological evidence of complex civilization in Egypt at 10,500 BCE, that the artistic style of the Sphinx is consistent with Old Kingdom work, and that the rainfall erosion could result from other factors, including brief periods of increased rainfall in Egypt's more recent past, or water used during construction and later ritual activities. The debate remains unresolved, but the possibility that the Sphinx predates conventional chronology by thousands of years challenges our understanding of when and where civilization emerged. In South America, the site of Tiwanaku near Lake Titicaca in Bolivia contains megalithic architecture that some researchers argue predates the conventional dating of approximately 200 CE to 1000 CE for the main Tiwanaku culture. The site's most famous structure, the Gateway of the Sun, is a single massive block of andesite weighing approximately 10 tons, carved with elaborate designs, including a central deity figure surrounded by rows of smaller figures, some with human forms and others with animal features. Arthur Poznański, an Austrian engineer who studied Tiwanaku extensively in the early 20th century, argued based on astronomical alignments that the site was constructed around 15,000 BCE, placing it well before the Younger Dryas. His analysis was based on the orientation of structures relative to the cardinal directions and calculations of how Earth's axial tilt, which varies slowly over tens of thousands of years, would have affected sunrise and sunset positions at the site's latitude in antiquity. Mainstream archaeology has largely dismissed Poznański's chronology as based on flawed astronomical calculations and contradicted by radiocarbon dating of organic materials from the site that consistently place the main construction phases in the first millennium CE. However, some researchers argue that the radiocarbon dates reflect later occupation and renovation of much older structures, that the foundations and megalithic elements represent earlier construction phases, and that the astronomical alignments Poznański identified are too precise to be coincidental. The possibility that Tiwanaku, or at least its underlying megalithic foundations, predates the Younger Dryas remains speculative, but cannot be definitively ruled out without more extensive archaeological investigation of the site's deepest and oldest layers. Like Göbekli Tepe and the Sphinx, Tiwanaku may represent either construction by an advanced pre-Younger Dryas civilization or immediate post-Younger Dryas construction by survivors rebuilding with knowledge inherited from before the catastrophe. Just as the knowledge of agriculture, architecture, and astronomy preserved by survivors of a flood could enable rapid reconstruction of civilization once conditions stabilized, so too might survivors of the younger Dryas impacts have retained sufficient knowledge to build sophisticated structures immediately after the climate catastrophe ended, creating the impression of advanced civilization suddenly appearing in the archaeological record without apparent developmental stages. This pattern of sudden appearance without clear precedent characterizes multiple early civilizations. The Sumerians appear in Mesopotamia around 4000 BCE, already possessing writing, mathematics, sophisticated irrigation systems, monumental architecture, complex religious systems, astronomical knowledge, and legal codes. Egyptian civilization emerges around 3100 BCE with the unification under the First Dynasty, apparently already possessing the organizational capabilities, technical skills, and cultural sophistication to build pyramids within a few hundred years. The Indus Valley civilization appears around 3300 BCE, with planned cities featuring advanced sewage systems, standardized weights and measures, and widespread literacy indicated by the undeciphered Indus script found on thousands of seals. These civilizations do not show gradual development from simple to complex over many centuries, but rather seem to arrive in history nearly fully formed, as if reconstructing from a template rather than inventing for the first time. This observation leads us to one of the most profound questions we must ask, and I want to be very direct about the implications here, because this is where the evidence becomes either compellingly suggestive or dangerously speculative, depending on your perspective. If advanced civilization existed before the younger Dryas, possessed knowledge of astronomy, mathematics, engineering, and possibly technologies we would recognize as advanced even today, and if that civilization was largely destroyed by cosmic impacts, leaving only scattered survivors, what would we expect to find in the archaeological and geological record? We would expect exactly what we do find: megalithic ruins at scattered locations that predate known civilizations, or that are far more sophisticated than the societies conventionally credited with building them, suggesting either much earlier construction or inheritance of knowledge from an earlier civilization. Flood myths and catastrophe traditions present in virtually every culture globally, preserving fragmented memories of the actual catastrophe experienced by ancestral populations. Encoded astronomical knowledge in myths, monuments, and sacred sites, representing deliberate attempts by survivors to preserve crucial information about the cosmos and potentially about the specific threat that destroyed their civilization as a warning to future generations. Sudden appearance of complex civilizations in the early Holocene, apparently already possessing advanced knowledge rather than developing it gradually, consistent with reconstruction using preserved knowledge rather than invention from scratch. And perhaps most tellingly, a pattern of civilization reset, where humanity appears to reach a certain level of complexity, then collapses, then rebuilds, a cycle that could reflect recurring cosmic impacts from the same source. Just as floods of knowledge were shared by those who survived ancient catastrophes to help rebuild what was lost, this channel explores and shares evidence and interpretations that challenge official historical narratives, inviting you to examine information typically excluded from mainstream discourse. If this approach resonates with you, if you value investigations that dare to question established timelines and consider alternative explanations for the origins of civilization, I invite you to subscribe to this channel. By subscribing, you ensure you will receive notification of future documentaries, where we will continue exploring these questions, including detailed examinations of specific megalithic sites, analysis of ancient astronomical knowledge encoded in monuments, and investigations of the recurring cosmic threat that may have destroyed civilizations multiple times throughout human history. Your subscription directly supports our ability to produce comprehensive research-based content that respects your intelligence while challenging you to think beyond conventional boundaries. Now let us examine the global pattern of flood mythology and catastrophe traditions, because these stories, preserved across hundreds of cultures, provide our most direct access to how ancient peoples understood and remembered the younger Dryas event, or whatever catastrophe their traditions describe. Flood myths are nearly universal in human cultures, found on every inhabited continent, and in regions geographically separated by thousands of kilometers with no historical contact until recent centuries. While details vary, the core narrative structure recurs with remarkable consistency. There was a time before when either gods or an advanced previous humanity existed. Human wickedness, overpopulation, or divine decision led to the decision to destroy the world through flooding. A righteous individual or small group was warned and built a boat or escaped to high ground. The flood covered the earth, destroying nearly everything. The survivors eventually found land and repopulated the world, often with divine assistance or teaching that enabled them to rebuild civilization. The biblical account in Genesis chapters 6 through 9 is perhaps the most familiar flood narrative in Western culture. God observes that human wickedness is great and decides to destroy humanity through flood, but Noah finds favor with God, is warned, and instructed to build an ark to specific dimensions, 300 cubits long, 50 cubits wide, 30 cubits high, approximately 137 meters by 23 meters by 14 meters, a vessel large enough to carry Noah, his family, and breeding pairs of all animal species. The flood lasts 40 days and 40 nights, then gradually recedes over months, with Noah sending out birds to test whether land has emerged. Eventually, the ark comes to rest on the mountains of Ararat. Noah and his family and the animals disembark, and God makes a covenant never to destroy the earth by flood again, setting the rainbow as a sign of this promise. Conventional biblical scholarship typically interprets the flood narrative as either pure mythology, serving theological purposes, demonstrating God's justice and mercy, or as an exaggerated folk memory of a regional flood in Mesopotamia that seemed universal to the population experiencing it. The parallels between the biblical flood and Mesopotamian flood narratives are so close that most scholars accept that the Genesis account is derived from or shares common sources with the earlier Mesopotamian traditions. The Epic of Gilgamesh, composed around 2100 BCE but incorporating earlier material, includes the flood story told by Utnapishtim, who survived the deluge. In this account, the gods decided to destroy humanity through flooding, but the god Ea warned Utnapishtim in a dream and instructed him to build a boat, providing specific dimensions, cubical in shape, 120 cubits per side. Utnapishtim built the boat, loaded it with family, craftsmen, animals and supplies, then sealed the door as the storm began. The flood lasted 6 days and 7 nights, after which Utnapishtim opened a window and sent out birds to test for dry land. First a dove that returned, then a swallow that returned, then a raven that did not return, indicating land was available. When Utnapishtim finally disembarked and made sacrifice, the gods smelled the sweet savor and gathered around the offering. Enlil was angry that any humans survived, but Ea defended his action, and ultimately Utnapishtim and his wife were granted immortality and taken to live at the edge of the world. The even older Sumerian account found in the Eridu Genesis, dating to approximately 1600 BCE in its written form, but based on earlier traditions, describes how the gods created humans, how humanity multiplied and became noisy, disturbing the gods, how Enlil decided to destroy them with a flood, and how Enki warned King Ziusudra, who built a boat and survived. After 7 days and 7 nights of flooding, the sun god Utu appeared, the waters receded, and Ziusudra made sacrifice to the gods, receiving eternal life as reward. These Mesopotamian accounts are clearly related to each other and to the biblical narrative, and since the Mesopotamian versions are demonstrably older, the direction of influence seems clear, but the question remains whether these stories preserve actual historical memory or are purely mythological. Outside the biblical and Mesopotamian traditions, flood myths appear globally, with details that sometimes align closely with the Middle Eastern versions and sometimes differ significantly. Greek mythology includes the story of Deucalion and Pyrrha, who survived a flood sent by Zeus to destroy the corrupt Bronze Age of humanity. Warned by Prometheus, Deucalion built a chest or ark, and he and his wife floated for 9 days until coming to rest on Mount Parnassus. When the waters receded, they repopulated the earth by throwing stones over their shoulders, which transformed into humans. Hindu tradition preserves the story of Manu in the Matsya Purana and other texts. Manu was warned by a fish avatar of Vishnu that a great flood would destroy the world. Manu built a boat, and when the flood came, the fish towed the boat to safety, eventually to the peak of the Malaya mountain. From there, Manu descended and performed penance and sacrifice, eventually receiving a wife from whom all subsequent humanity descended. The details about being towed by a fish are unique to this tradition, but the core elements of warning, boat building, survival, and repopulation mirror other flood narratives. Chinese tradition includes multiple flood accounts, most famously the Great Flood in the time of Emperor Yao and the labors of Gun and Yu to control the flooding waters. While Chinese flood myths often emphasize flood control and water management rather than total destruction and survival through boat, they preserve the tradition of catastrophic flooding in antiquity that required heroic efforts and divine assistance to overcome. Native American traditions across both continents include numerous flood narratives with remarkable variety. The Ojibwe tradition describes the hero Nanabojo, who warned of a coming flood, with some people surviving by climbing to the highest mountain, while Nanabojo built a raft and floated above the waters with various animals. After many days, Nanabojo sent animals diving to try to find Earth, and eventually Muskrat succeeded in bringing up a small amount of mud, which Nanabojo used to recreate the land. The Cherokee tradition describes a great flood that covered all the land except the highest mountain peaks, where people and animals took refuge. As the waters receded, a buzzard was sent out to find land, and the flapping of its wings created the valleys and mountains of the Cherokee homeland. Aztec tradition preserved in the Codex Chimalpopoca describes multiple creations and destructions of the world, with the fourth sun destroyed by flood when the sky fell and waters came up from below, lasting 52 years. Only one couple, Tata and Nena, survived by hiding in a hollow log, and from them the current human race descended. Inca tradition describes a flood sent by the creator god Viracocha to destroy the giant race of the previous era, with two people surviving by taking refuge in a cave or sealed vessel, then repopulating the world after receiving instruction from Viracocha. Oceanic traditions also include flood accounts. Maori tradition from New Zealand describes how the hero Tauhaki caused flooding that covered the land in vengeance against those who mistreated him, with people surviving on mountain peaks or in canoes. Hawaiian tradition describes a great flood named Kayakahina Ali'i that destroyed ancient peoples, with some surviving by climbing to the summit of Mauna Kea and Mauna Loa. Australian Aboriginal traditions include flood stories from multiple regions, such as the Dreamtime accounts of a great flood that reshaped the land and that only a few people and animals survived by climbing trees or mountains. The global distribution of flood myths has been documented extensively by folklorists and comparative mythologists. One systematic survey identified flood myths in over 200 cultures across all inhabited continents, making it one of the most widespread mythological themes in human tradition. Conventional anthropology and comparative religion offer several explanations for this distribution that do not require an actual global flood. First, localized catastrophic flooding occurs relatively commonly in river valleys, coastal regions, and areas subject to glacial lake outburst floods, creating traumatic events that become embedded in cultural memory and oral tradition, eventually growing into mythological accounts of universal floods. Second, many human settlements historically developed near water sources, including rivers, lakes, and coasts, making flooding a recurring hazard that would naturally feature prominently in cultural narratives. Third, the flood narrative provides a useful mythological structure for explaining the origin of current humanity, as distinct from a previous age, allowing cultures to assert their own uniqueness and special relationship with the divine. Fourth, diffusion of flood myths from original source cultures to other cultures through migration, trade, conquest, or cultural exchange could account for the widespread distribution without requiring independent development everywhere. These explanations are plausible and likely account for some flood myths, but they struggle to explain the specific commonalities across geographically separated traditions that had no historical contact. Why do so many flood myths include the specific detail of a righteous survivor who receives divine warning, builds a boat, or takes refuge on a mountain, sends out birds to test for dry land, and receives special divine favor afterwards. Why do many traditions specify that the flood was sent deliberately by gods or God to destroy a previous wicked or overpopulated humanity? Why do some traditions include details about the flood lasting a specific duration, such as 40 days, 7 days, or 52 years? These narrative commonalities suggest either very ancient common origin, predating the dispersal of human populations, or actual historical basis, with the myths preserving distorted but real memories of a catastrophic event experienced by ancestral populations globally. The alternative interpretation proposes that flood myths preserve genuine historical memory of the Younger Dryas catastrophe, specifically the combination of impacts, firestorms, ice sheet melting, and subsequent flooding that accompanied the cosmic impacts 12,900 years ago. The warning received by the flood hero could represent information from astronomical observers who detected the approaching comet and recognized the danger, allowing some populations to prepare and take refuge. The emphasis on high mountains and boats reflects the two most plausible survival strategies during catastrophic flooding, seeking high elevation or creating floating vessels. The sending out of birds reflects actual post-flood behavior, as survivors tested whether land had emerged and whether ecosystem recovery had progressed sufficiently to support human life. The granting of divine favor or special status to survivors represents the real social reality that those who survived became the seed population for subsequent humanity, with their descendants claiming special status as carriers of pre-flood knowledge and civilization. The global distribution reflects the global or at least hemispheric scope of the Younger Dryas impacts and climate catastrophe, which affected populations across multiple continents, ensuring that survivor populations everywhere preserved memories of the event. The fact that many flood myths include fire as well as water, describing how fire rained from the sky before or during the flood, supports the impact interpretation, because cosmic impacts would indeed produce both fire from thermal radiation and airbursts, as well as flooding from ice sheet melting and climate disruption. The Ojibwe tradition specifically describes the waters rising from below and falling from above simultaneously, consistent with the combination of melting ice sheets and atmospheric precipitation that would accompany impact-induced climate catastrophe. The Aztec account of the sky falling and waters coming from both above and below similarly describes a scenario more complex than simple flooding, suggesting catastrophic disruption of the entire environment, both atmospheric and terrestrial, exactly what would occur during major cosmic impacts. Some flood myths include even more specific details that seem to reference cosmic phenomena. The Hawaiian flood narrative mentions that the flood was preceded by the appearance of bright lights in the sky and the sound of thunder without storm clouds, descriptions consistent with meteorite or comet fragment entry and airburst. Several Native American traditions describe the stars falling from the sky or the sky itself, fracturing or being torn open before the flood, imagery that could represent observation of intense meteor showers or atmospheric disruption caused by comet fragment entry. The Babylonian account in the Atrahasis epic describes the approach of the flood in terms that sound more like cosmic catastrophe than simple storm. The Anunnaki lifted up their torches, setting the land ablaze with their flare. The description of gods carrying torches that set the land ablaze could be mythological interpretation of meteor impacts and resulting firestorms observed from a distance. Several South American flood traditions describe twin disasters, a world destroyed first by fire then by water, or alternatively cycles of destruction where worlds are alternately destroyed by different means. This could reflect the sequence of events during the Younger Dryas impacts, with initial fire from thermal effects and continent-scale burning followed by flooding from ice sheet collapse and climate disruption. If these myths do preserve memories of the Younger Dryas catastrophe, they represent an extraordinary feat of cultural transmission, maintaining recognizable narrative structure across 12,900 years through potentially 500 to 600 generations of oral tradition before being recorded in writing. This challenges assumptions about the reliability of oral tradition for preserving historical information. But anthropological research has demonstrated that some indigenous cultures can maintain remarkably consistent oral traditions across many generations, particularly for events of special cultural significance. The Aboriginal Australians, for instance, have oral traditions that appear to preserve accurate information about coastal geography from periods when sea levels were lower, suggesting their traditions extend back at least 10,000 years to the end of the last ice age. If Australian Aboriginals can preserve topographical information for 10,000 years, it is plausible that other cultures could preserve narratives about catastrophic events for similar durations. Now we must address the most controversial aspect of the lost civilization hypothesis: the claim that this pre-Younger Dryas civilization possessed not merely Stone Age hunter-gatherer sophistication, but advanced technology possibly approaching or even exceeding modern capabilities in some domains. This claim goes beyond suggesting that ancient peoples built impressive megalithic structures or possessed sophisticated astronomical knowledge, proposing instead that the destroyed civilization had achieved technological advancement that we would recognize as high-tech or even beyond our current understanding. The evidence for this proposition is admittedly more speculative and relies heavily on interpretation of ancient texts describing technological marvels, out-of-place artifacts that seem too advanced for their supposed time periods, and architectural precision that allegedly requires advanced tools and methods. Proponents of ancient high technology point to objects like the Antikythera mechanism, a complex geared astronomical calculator recovered from a shipwreck dating to approximately 100 BCE, demonstrating technological sophistication not matched again until medieval clockwork. If ancient Greeks in the 1st century BCE could construct such sophisticated mechanical computers, why should we assume earlier civilizations lacked technological capabilities? The Antikythera device proves that absence of evidence is not evidence of absence, that sophisticated technologies can exist in antiquity without leaving obvious archaeological traces because mechanical devices corrode and decay unlike stone structures. Critics counter that the Antikythera mechanism, while impressive, is not evidence of lost high technology, but rather demonstrates that ancient Greeks possessed exactly the technological capabilities that historical sources describe: expertise in bronze working, gear cutting, and astronomical observation that could be combined to create such a device. The fact that we have only one known surviving example suggests it was rare and specialized, rather than representative of widespread technological advancement. Regarding claims of ancient machining of stone surfaces to precision tolerances requiring modern tools, skeptics demonstrate that patient handwork with abrasives can achieve remarkable precision given sufficient time and skill, that ancient craftspeople were capable of extraordinary work using simple tools, and that attributing ancient achievements to lost high technology diminishes the real accomplishments of our ancestors who achieved impressive results through skill, patience, and accumulated knowledge rather than advanced machinery. The debate over ancient technology often centers on specific artifacts or structures whose construction methods seem difficult to explain using known ancient techniques. In Peru, the stone walls at Sacsayhuaman and other Inca sites feature polygonal masonry, where massive stones weighing many tons are fitted together with joints so precise that a knife blade cannot be inserted between stones, and the joints follow complex irregular three-dimensional surfaces rather than simple planar cuts. How did Inca stoneworkers, supposedly using only bronze and stone tools since they lacked iron, achieve such precision? Conventional archaeology proposes that they used a combination of methods, including repeated heating and cooling to fracture rock along desired lines, pecking with harder stone hammers to shape surfaces, grinding with abrasive sand to achieve final fit, and trial and error fitting where stones were repeatedly placed, marked where they contacted adjacent stones, removed and ground to improve fit, then replaced, repeating the cycle until perfect fit was achieved. This explanation is plausible and supported by experimental archaeology, where modern workers, using reconstructed ancient tools, have successfully shaped and fitted similar though smaller stones. However, alternative researchers argue that the scale of work at sites like Sacsayhuaman involving hundreds of massive stones, each requiring enormous labor to quarry, transport, and fit, makes the conventional explanation impractical, that the time and labor required using hand methods would be prohibitive, and that some of the precision jointing shows characteristics more consistent with machining than handwork. The debate remains unresolved largely because we cannot definitively prove what methods were used. We can only demonstrate what methods are possible. In Egypt, the precision of the Great Pyramid's construction continues to generate debate. The base of the pyramid is level to within 2 centimeters over a side length of 230 meters, an accuracy of better than 0.01%. The sides are oriented to the cardinal directions with an error of less than 0.05 degrees. The internal pass, ages and chambers are constructed with granite blocks fitted together with tolerances measured in fractions of a millimeter. The king's chamber in the Great Pyramid is composed of red granite transported from Aswan over 800 kilometers away, with individual blocks weighing up to 180 hartext tons doma. How were these blocks lifted and placed at a height of 43 untext meters do with such precision? Modern engineering analysis suggests that while possible using ramps and large labor forces, the complexity and precision of the work are consistent with more advanced methods. Christopher Dunn, a precision machinist, argues that the surfaces of the granite blocks show evidence of machining, including high-speed drilling and sawing, that would be difficult to replicate without modern power tools. He points to the sarcophagus in the king's chamber, which is carved from a single block of granite and shows evidence of being hollowed out using a drill that advanced into the stone at a rate much faster than possible with hand tools. Mainstream Egyptologists reject these claims, noting that experimental archaeology has demonstrated how copper saws and tubular drills used with abrasive sand can cut granite, albeit slowly. But the question remains, why would they invest such extraordinary effort in achieving precision that is invisible to the casual observer and seemingly unnecessary for the structural integrity of the pyramid? This interpretation of ancient high technology divides researchers into 2 camps. Some say the evidence for advanced tools is undeniable once you look with the eye of a modern engineer, while others insist that human ingenuity and a massive workforce are sufficient to explain any megalithic wonder. What do you think? Was the Great Pyramid the product of primitive labor pushed to its limits, or does it whisper of a technological age we have forgotten? Share your perspective in the comments as we dive deeper into these conflicting narratives. As we consider these physical anomalies, we must also look at the perspective of ancient astronaut theorists like Zecharia Sitchin, who proposed that the Younger Dryas was not merely a random natural disaster, but an event deeply entwined with the presence of an extraterrestrial race he called the Anunnaki. According to Sitchin's translations of Sumerian texts, the Anunnaki knew of the impending catastrophe. The Epic of Atrahasis suggests a chilling disregard for human life among the higher ranks of these beings. It states, "The noise of mankind has become too intense. I am losing sleep over their uproar. Let there be a flood to wipe them out." In Sitchin's view, the Younger Dryas impact was caused by the gravitational influence of a celestial body, Nibiru, passing through the inner solar system, which destabilized the Antarctic ice sheet or pulled a comet into a collision course with Earth. The gods decided to let the catastrophe happen to solve the problem of human overpopulation, with only Enki secretly intervening to save a remnant of the species. This provides a radical context for the Younger Dryas. It was a deliberate reset of a biological experiment. Just as Enki shared forbidden knowledge with humanity to ensure our survival, this channel shares investigations that challenge official narratives of our past. If these revelations about our hidden history resonate with you, consider subscribing to accompany us on this journey as we piece together the fragments of the first civilization. Returning to the physical evidence, we move from the desert of Egypt to the high Andes. In Pumapunku, Bolivia, we find diorite and andesite blocks carved with such geometric precision that they feature internal right angles and H shapes that look like they were produced by a computer-controlled milling machine. The blocks are composed of incredibly hard stone, yet they contain fine grooves and holes that are perfectly straight and consistent in depth. Calculations suggest that to carve these blocks by hand with stone tools would require thousands of hours per block, yet there are hundreds of them. Furthermore, the blocks were designed to interlock like a giant modular construction set, implying a level of pre-planning and engineering sophistication that predates the Inca by millennia. Conventional archaeology dates Puma Punku to approximately Hos 500 one text CE and NE, attributing it to the Tiwanaku culture. However, the lack of developmental stages for this technology in the region is a major anomaly. It appears suddenly, perfectly executed. Could it be that Puma Punku is actually a remnant of the pre-Younger Dryas world? If we look at the weathering on these stones, some geologists suggest it may have been exposed to the elements for much longer than Napi 1500 frontext years Nanatar. There is a specific detail about the soil at Tiwanaku that we will discuss when we reach the section on ancient physics. It involves a layer of sediment that seems to have been deposited by a massive wave of water that reached an altitude of 3,800 text in meters. Eorv. This brings us to the connections between cultures that were supposedly isolated. Across the world, we find the symbol of the handbags of the gods. In the reliefs of Göbekli Tepe, in the carvings of the Sumerians, and in the stone sculptures of the Olmecs and Mayans in Mesoamerica, we see deities or culture bringers carrying a specific type of bucket or handbag. Why would cultures separated by the Atlantic and thousands of years all depict their gods with the exact same accessory? Alternative researchers suggest this handbag was a container for knowledge, or perhaps a technological device used to seed civilization after the Younger Dryas reset. In the Sumerian myths, these beings are the Oans, or the Seven Sages, who emerged from the sea to teach men writing, agriculture, and law. They brought with them the Mi, the divine decrees of civilization, says the Lament for Ur. If the Younger Dryas was a global catastrophe, these sages would be the survivors of the high-tech pre-impact world, traveling to different corners of the globe to restart the human project. They were the architects of the new era, the ones who provided the blueprints for the pyramids and the ziggurats. But who were they? Some suggest they were a surviving elite of a lost maritime culture like Atlantis, while others, following the Sitchin narrative, believe they were the Anunnaki returning to Earth's surface to reclaim their laboratory. Modern science is beginning to catch up with these ancient claims through the study of DNA. In the last decade, geneticists have identified ghost populations in the human genome, DNA from ancestors for whom we have no fossil record. For instance, the genomes of some West African populations contain up to 19% of their ancestry from an unknown hominid that split from the human line before the Neanderthals. Even more intriguing is the discovery of the K haplogroup and its mysterious expansion around Yasha's 12,000 Hortext years Aisar. Some researchers speculate that the sudden appearance of certain genetic markers in the Middle East and Europe at the end of the Younger Dryas could represent the influx of a specific survivor population, the Atlanteans or the Anunnaki hybrids who carried the knowledge of agriculture. This aligns with the refugia theory in biology, which states that during times of extreme climate stress, populations retreat to sheltered areas. If the Younger Dryas was an impact winter, these refugia would be the cradles where the next version of humanity was prepared. This leads to a provocative question. No one has satisfactorily explained how agriculture appeared in multiple places, the Levant, China, and the Americas, almost simultaneously after the Younger Dryas. Can you think of an alternative explanation other than a coordinated seeding of knowledge? Theories of independent invention are common, but the timing is suspicious. Creative ideas are welcome in the comments. The technological descriptions in ancient texts often go beyond flying boats. In the Mahabharata, there is mention of the Agneya weapon, a blazing shaft that possessed all the power of the universe. It is described as follows: a single projectile charged with all the power in the universe, an incandescent column of smoke and flame as bright as 10,000 suns rose in all its splendor. It was an unknown weapon, an iron thunderbolt, a gigantic messenger of death. To a reader in the Malm 19 text century N, this might have sounded like a poetic description of a volcano or a storm. To a reader in the Malm 1 text century N, it sounds like a tactical nuclear strike. If a pre-Younger Dryas civilization possessed nuclear or directed energy weapons, a global war could have been the catalyst that weakened them before the final comet impact finished the job. This would explain the layers of vitrified stone found in ancient forts in Scotland and in the ruins of Hattusa in Turkey. Vitrification, the turning of stone into glass, requires temperatures in excess of das 100 don. Search, text, C. While some scholars argue this was the result of long-duration forest fires or intentional siege fires, the sheer scale of the melting suggests a thermal pulse of immense intensity. This ties back to the Younger Dryas impact hypothesis. The iron thunderbolt from the myths might be the ancient way of describing a fragment of a comet entering the atmosphere at mean around 30,000 miles per hour. We will explore the specific physics of these vitrified sites in future documentaries, as they may hold the key to understanding ancient metallurgy. Subscribe to follow these revelations as we continue to map the evidence of a forgotten global conflict. Meanwhile, we must look at the perspective of mainstream science. Critics argue that the Younger Dryas impact is a zombie theory that refuses to die despite lacking a clear crater. They point out that a comet large enough to cause global cooling should have left a massive, undeniable scar on the Earth's surface. Proponents respond by pointing to the Hiawatha crater beneath the Greenland ice, which is Vartuus 31 text kilometers wide. While initial dating suggested it might be much older, some researchers believe it could be the smoking gun of the Younger Dryas. But even without a single large crater, a fragmented comet, a comet train like Shoemaker-Levy 9, would produce multiple airbursts that wouldn't necessarily leave craters but would incinerate the surface. This is the Cape York meteorite shower on a planetary scale. The controversy divides the scientific community, but as new sediment samples from the Pilauco site in Chile show similar microspherules and nanodiamonds, the impact side is gaining ground. It suggests that the catastrophe was indeed global, stretching from the Arctic to the southern tip of South America. This brings us to a cultural connection that is often overlooked: the calendar. The Sumerians, the Mayans, and the Egyptians all shared a fascination with the number 12960 and its multiples, which are related to the precession of the equinoxes. The Great Year, a cycle of 25,120 text years, was known to these cultures long before the invention of the telescope. Why were they so obsessed with the slow wobble of the Earth's axis? Some suggest it was because they knew the comet's return was linked to these precessional cycles. The hidden records mentioned in the Sumerian king list might be astronomical tables meant to predict the next reset. If we identify connections between these cultures' calendars and the timing of the Younger Dryas, we might find a warning meant for us. Do you know of other cultures with myths of a recurring fire from the sky, or specific Great Year cycles? Share them in the comments, as these cultural echoes often hide the most profound truths. As we transition into the next phase of our investigation, we will look at the forbidden artifacts that didn't just survive the flood, but were allegedly used to restart the world's power systems.